Okay, here is the last set of reviews. We're looking at electricity, where the three parts make up an atom. We know that the protons are positive and the neutrons are neutral, and they're both in the nucleus. We know the electrons are negative and they're in shells or clouds or in orbit outside of the nucleus. What's electricity made of? That's easy, electrons. Fill in the chart for the following energy conversion. So a generator changes kinetic energy, that's motion, to electrical. Electrochemical cell changes chemical energy into electrical energy. A St. Louis motor changes electrical energy into kinetic energy. Incandescent light bulb changes electrical energy into light and thermal energy. Piezoelectric crystal changes electricity into kinetic energy or sound. And a thermocouple will change heat energy or thermal energy into electrical energy. Discuss whether the following electrical chemical cells will work. So it has to have two different electrodes and an electrolyte for this to work. So zinc and zinc electrode, acid electrolyte won't work. Electrodes are wrong. Zinc and copper electrodes, acid electrolyte works. You have a conducting electrolyte, you have two different metals. Copper and tin electrode, saltwater electrolyte works. Not very well, but it will work because two different metals, and you have the salt water which conducts. Copper and tin electrodes, distilled water. No, distilled water doesn't conduct electricity. It's not an electrolyte, so that won't work. If you have a need for 12 volts, but you have only a box of 2-volt cells, how can you accomplish this? You would combine 6 cells together, arrange in series, pluses to minus. If you have a box of 2-volt cells and the device only requires 2 volts, but you need the device to stay on unattended for a full year, how would you accomplish this? You would tie them together, that is, arrange them in a parallel circuit, so you essentially make a giant 2-volt cell. What's the part of the St. Louis motor that reverses the current? That's the split ring commutator. What's the part of electromagnet that's free to spin? That's called the armature. What can be done to increase the speed of a St. Louis motor? You can use stronger magnets, a stronger armature with more coils. You can use a bigger battery to power it as well. You can use a better conductor. What type of electricity can build up? Static or current? That's easy, current. What are the 3 laws of charges? Opposites attract is the first one. Similar charges repel is the second one. And charge objects attract neutral ones. Classify the following as conductor, insulator, or resistor. So rubber is an insulator, iron metal, that's a conductor, nichrome is a resistor, allows some electricity to flow, not all. If you're sweating, will the resistance across your skin increase, decrease, or stay the same? Sweating has salt water in it, and so your resistance will decrease, so more charge can flow. In a rheostat, variable resistor, the resistance can change. If we slide the switch so that the electricity passes through more resistance, what happens to the brightness of the bulb? It becomes less bright. Ohm's Law, here is the formula. Write the other 2 versions of it. So you need to be able to manipulate your formula to do this. I showed you how to do that with either the circle or if you are good at algebra. 120 volts is applied to a light bulb, 5 amp flows. Calculate the resistance of that bulb. So R equals V divided by I, R equals 120 divided by 5, R is 24 ohms. In a river flowing down a mountain analogy, what would voltage, current, and resistance be? Current would be how much water flows per second. Resistance would be what's slowing the flow, so it could be bends in the creek or it could be the rocks on the bottom. Voltage would be the gravity that's pulling it down the mountain. And here we can see as current increases, voltage increases. So the question says, as voltage decreases, what happens to current? It decreases. What's the slope of this equal to? V divided by I, that's resistance. If a parallel circuit and series circuit both have the same number of cells and light bulbs, which one will have the dimmest bulbs? That would be the series circuit. In what kind of circuit can you turn devices on one at a time without affecting the others? That has to be a parallel circuit. In a parallel circuit, all bulbs will be the same brightness and they will all be bright, right? In a series circuit, they'll all be the same brightness, but they'll all be dim. A digital device has millions of switches and they are called transistors. And remember, they'll have smaller voltage, smaller current, smaller resistance as well. A digital device has lower current going through than an electric blender. Circuit diagram here says you need to have a parallel circuit with 1 motor, 2 lights, two switches to turn lights on and off. One variable resistor controls the speed of the motor, and the motor runs continuously, and you're able to turn lights on and off. What would happen if you had one more light bulb? It would stay bright. And as one bulb burns out, the other ones stay on, right? It's parallel circuit independent control. Here's a series with one motor, two lights, 4-cell power source, and an open switch. If one bulb burns out, the other one, everything turns off, right? If you add another light bulb to the circuit, the current slows down, so the motor runs slower, the lights are less dim. The advantage of this, the battery lasts longer. The advantage of the parallel circuit is, yeah, the battery goes out quicker, but everything has full power. Power calculation, you need to be able to rearrange that formula. So I showed you how to do that with the circle in class, or you could use your algebra skills. 13 amps is flowing through 12-volt power source. Calculate the power rating. So P is equal to I times V, 13 times 12, 156 watts. Given this formula, E equals P over T. Here's the two versions of the formula, and here's the units for them. Power is in watts, time is in seconds, energy is in joules. In a circuit, 60-watt light bulb runs for 2 minutes. How much energy flows? Remember, change the 2 minutes into seconds, multiply them, and you get 7,200 joules. Calculating efficiency. So remember that's that's output divided by input times 100. Although I taught you there's nothing as 100% efficient, so all you have to do really small divided by big times 100, and that would make A the most efficient. That was an actual question off of PAT. Name some ways to conserve electricity in your home without having a negative environmental impact. Turn off lights when they're not being used. Buy more efficient devices. Use dimmer switches as well. Unplug things that are not being used. Safety-related equipment with electricity. We talked about this. Don't plug in too many devices. Use GFCI. Always make sure that the third prong is there for things. Don't cut them off. Avoid overhead wires. Replace any frayed wires, and avoid combining them with water. And then here, pros and cons of different ways of generating electricity. So you need to know about whether it's renewable or not, what environmental effects it has, the input energy and the output's always going to be electricity, but you need to know the input energy for each of those. And that is everything.